next speaker is a software engineer at Chronosphere, and she builds tooling for other engineers and loves automating things. To build or not to build? That is the question, and Mary has all the answers. Welcome, Mary Fesenko.
Yeah. Hi, everyone. As Daria already mentioned, my name is Mary, and I'm a software engineer on the infrastructure team at Chronosphere. And today, I would like to tell you about how deployment tooling evolved at Chronosphere. But first of all, a little bit about me and why am I actually talking about deployment tooling. So I was born and raised in Ukraine, in a beautiful city called Kharkiv. I studied there, I started working there in various outsourcing companies. And then in 2017, I moved to Denmark to work for Uber, and there I joined the infrastructure team. So that was my first experience working on the infrastructure team, and also first experience working on the teams that built their own deployment tooling. That was really exciting. I learned a lot, worked with really brilliant engineers, and saw a lot of cool tools in action. And then in 2020, I moved to Lithuania to work for Chronosphere, where, surprise, surprise, I ended up being on infrastructure team again. And then after a couple of months at Chronosphere, I kind of naturally gravitated toward deployment space again, because of past experience in general, I was really interested in the subject. So, long story short, when our company was just 1.5 years old, we took a little bit of an unconventional decision to build our own deployment system. And now it's been 2.5 years since that happened, and basically I want to look back at that journey and share with you why we did it, how we did it, and what we learned in the process of doing it. But before answering the question why, let's just talk a little bit more about what Chronosphere is, because I don't expect you to know about it. It's a hosted observability platform that is built to handle the scale and complexity of cloud-native metrics. We built it on top of M3DB, which is a time series database that was built at Uber, battle-tested there at scale, and then later open-sourced. And basically, we're building a new and exciting observability product on top of this solid foundation that we have in M3DB. So, when we're talking about Chronosphere, what does it actually mean to deploy it, right? So all of our software runs in the cloud. Our clusters are managed by Kubernetes. And then for each paying customer of Chronosphere, we call them tenants, we deploy them a completely separate Chronosphere stack for them. And basically, tenants in our setup are modeled as Kubernetes namespaces. And then in each of the namespaces, we deploy a bunch of stateful components and stateless components. And it's important to note that for our stateful stuff, which is M3DB, M3 aggregator, parts of our time series database solution, we have custom Kubernetes operators for those services that help us basically maintain the state of the cluster. And then, how do people actually deploy things? Normally, one engineering team owns a bunch of services, and then each of the teams has their own set of validation tools and maybe their own release schedule, and basically they need to deploy a bunch of services to all the tenants that we have. And last but not least, for monitoring, we use our favorite observability platform, Chronosphere. So for us, it was also quite important that whatever deployment solution we will have, it will be possible for us to integrate with our own tool. So let's go back in time by 2.5 years and look at how deployment looked at Chronosphere back then. So first thing that we did, we basically built a simple CLI command. And the user would call it and say, hey, I want to deploy this subset of services to this particular tenant. The CLI would connect directly to our cluster. It would download the configuration that we expect to have for these services, connect to the cluster, compare it with the current state, generate the diff, show it to you in the CLI output, and ask you, hey, does this look OK? Are you ready to proceed? If everything looks OK, then you just click yes. Command applies the changes directly to the cluster, and then it completes. And can we consider deployment done at this point? Of course not, right? So this is when you, as an engineer, you have to do all the dirty work. First of all, you want to know, is actually my deployment making progress? Is it stuck? Did it complete already? So for that, we would normally use kubectl or some other ways to kind of check the statuses of the pods, see if it's making progress. Hopefully, you deployed it changed with no bugs, everything is coming up healthily, everything is great. 5 minutes later, you're sure all the services you wanted to deploy are up and running. Great. So what would you want to do next? Probably go to your favorite dashboard in Chronosphere tool, and then maybe look at different metrics for your services, make sure that memory is not spiking up too much, error rate is not increasing, everything looks fine. And in the parallel, you would want to also check that you're not getting any PagerDuty incidents or any other alerts that you might have. So after doing all of that, switching between all of those tools, at some point you decide, okay, this tenant is healthy, I'm done with the deploy, everything is great, but not so great because now you need to repeat all of this from scratch for each individual tenant, which is a little bit annoying. But first, let's try to think a little bit about the positives, right? So it was some minimal automation. It could have been less, right? And then our engineers were able to deploy changes to a group of services instead of just one service at a time, and that helped speed up the process a little bit. And another thing that was nice and that engineers liked, they could review the diff before starting the operation, just to validate that nothing is weird in it, that configuration doesn't look strange or anything. Now let's talk about all the bad and the ugly. Basically, all the drawbacks that we have right now are coming from one key point, that users are responsible for monitoring. And to do this monitoring, they need to switch between a lot of different tools, and it's just a lot of things you need to do. And let's be honest, nobody likes switching between 5 different pages and stressing out, is production healthy, or is something broken, and we might lose a customer, right? And then this whole situation is getting even worse because you need to repeat all of this for each tenant, and you're the only one who actually knows, did we deploy it everywhere? You can easily forget a tenant or mess up the order if you actually have some sort of order. And then all of this gets worse in case you deployed 3 tenants out of 6, and suddenly you find an issue, and you decide that the safest thing for you is to roll back, and then you're sitting there with sweaty hands, getting a headache right there, trying to figure out, how do I roll back everything fast? How do I make sure that I didn't forget one of the tenants when I rolled out to? Because you don't know, maybe the bug will surface there as well. And another thing that we didn't like about this approach, because the CLI had to connect to the cluster directly, it meant that we needed to give almost full production access to all engineering machines, and it's not really a great and sustainable way for us to continue from security point of view. So when we just had a couple of tenants, we could handle it, it was not a problem, but the business was growing, and we knew that we had to solve this somehow, because this was not really sustainable in the long run. So this is when we had to answer the question, to build or not to build. And before answering that, we decided to just try compiling the list of requirements that we have for our perfect deployment system, right? So things that made it onto the list of things we wanted to have. That it would be easy to model our Kubernetes setup within the tool, with tenants represented as namespaces and different service groups and things like that. We wanted to be able to have some additional custom health checks, especially for our stateful components such as M3DB, because losing any availability, that would be horrible for the business. So we needed to make sure that our deploys are super safe, and we needed to iterate on those checks and make them very flexible. And then, again, coming back to M3DB deploys, we already had the operators that were doing a lot of really good things. They allowed us to kind of maintain the state of the cluster, expand it, shrink it, and things like that. So we wanted to be able to reuse that code, and if the tool would be able to integrate with it, that would be perfect, right? And then all the basic things. You want to be able to track the progress. You want to get some signal and failure. Also, you want to integrate with your observability solution, Chronosphere in our case, right? In case something goes wrong, you want to be able to access logs easily to just debug it. And we wanted to make sure that if we go with a hosted solution, that we don't provide too much access to a third-party vendor to our infrastructure. Preferably, we would want to provide no such access. So this is the list of requirements we had at the end of 2020 when we needed to make a call. Do we try finding a solution that exists already, or do we build something? And we looked at different solutions that were on the market, but none of them were really fitting our use case. And now, since we had all of this list of the things that we wanted to do, we were kind of maybe we can just try building it. How hard can it be, right? So now let's talk about the how. basically, deployment process from the way we were seeing it was pretty clear. It was pretty clear sequence of steps. And that is easy expressed as a workflow. And previously, we had automated a lot of other workflows at the company using temporal. And we decided that it kind of fits this use case, and we already had experience running temporal workflows, so we just decided to use it for that as well. So temporal is an open-sourced workflow orchestration engine. Basically, how it works, you write a workflow in your language of choice, then you spin up some workers that connect to temporal cluster, and those workers are able to run the workflows that you want to run. And then when you initiate the workflow, temporal will make sure to schedule it evenly across your workers, and in case some temporary failure happens in a long workflow, then the step that failed will be retried until it succeeds on other workers. So this way, it provides us more resilience towards failure. So how did we actually structure our workflows, right? Let's go from the bottom here. The first workflow that we built was deploy service. That's exactly what it says in the name. It deploys one service, waits for the deployment to complete, and fails otherwise if it gets stuck or something. Deploy tenant workflow would orchestrate deploys within one tenant, kick off multiple deploy service workflows, wait for them to complete, maybe decide in which order they should go or whether they should be deployed in parallel. And in addition to that, this workflow would also perform some additional monitoring of the health of the tenant. So this is when we would check for the alerts in Chronosphere product and make sure that nothing new or critical started firing since we started the operation. And then the top-level workflow, orchestration workflow, is responsible for basically managing in which order do we deploy tenants, figuring out what do we do on failure, how do we roll back. So let's talk about how did the user flow change with this. Engineers would still be using the same CLI but a different command, but now the CLI would not connect directly to the cluster and require a lot of permissions. It would talk to deployer service. As you can see, we're really inventive with our naming scheme, right? And then the service itself would connect to the cluster, to temporal, and then the CLI would call out through the API to deployer, initiate the workflow, and then deployer will make sure that we're going through all the steps in a correct order, and in case something goes wrong, then the user will be notified. And the way we decided to notify them about failures is through really lightweight, simple Slack application integration. So this is an example of how it kind of looked in the earlier days. This is a Slack message you would get on failure. And there you would know which tenant the failure occurred in, what exactly caused the failure. Is it because the service is not starting up, or was there like a critical alert that fired? If it's an alert, there will be a link to it. And then the most important thing about this notification is that it actually provides you actions that you can take, how to handle the failure. In this case, you could either stop and leave it in the state that it's in right now for a testing environment that might be good for debugging and stuff. And then there's rollbacks that you would perform to kind of undo the changes that you have done and undo all the damage. And basically, this way, we exposed and made rollbacks much easier and more accessible. And in case you would be doing a deployment to multiple tenants, there would be also an option to roll back all tenants fast. And the rollback workflow would be basically the same deployment workflow, but started with a different set of options to make sure that we go back as fast as we can, as safe as we can. So now let's, again, focus a little bit like what happened after we rolled it out? Did it help? So the things that engineers liked, they liked that now they were able to deploy changes to multiple tenants. They were able to deploy maybe even to all tenants in the cluster. And then having automatic monitoring of deployment progress and deployment health was good. But then again, engineers are skeptical, so they didn't really trust us right away. So it took quite a bit of time. Like at the beginning, I know everybody was still using all the same 5 tools to check the status, but over time, we have gained engineers' trust, and these days, I believe most of people just rely on basically on deployer to decide whether deployment is healthy or not. And then we provided easier way for them to initiate a rollback, which was really important for us to keep our availability goals. And another thing that we got out of the box with it is a history of changes. Because sometimes, you're looking at the graphs for your service, and then you find out that on Thursday last week, suddenly there is a huge spike in memory usage, and it stayed like that. And then you kind of want to find out what happened. And with a history of changes, now you're able to do that. You're able to go back in time and find out was there a deployment happening at that time. And we didn't have that ability previously. But then, as we gathered more feedback after rolling it out to the teams, we found out that it was not perfect. It never is, right? Because different teams had different requirements. Some teams owned our stateful components, and they needed maybe to go a little bit slower and have a little bit more control. And for stateful components, they also had some additional requirements that maybe storage tier didn't have. Another thing that was kind of getting worse over time, as the business was growing, we were getting more tenants, and duration of this multi-tenant deploy was also increasing. And another issue that we faced as we were growing with the number of tenants, tracking the progress of a deploy was getting a little bit more annoying for a regular engineer. Let me show you why, right? Because we build everything in the CLI, right? So here's an output of like a status of deployment for 2 tenants, 9 services in each tenant. So like you can figure out a little bit what is going on here, but now let's imagine this with 10 tenants or even more. First of all, it doesn't fit the screen. And in general, who doesn't want to look at this wall of text, right? So neither did we. So this is when we decided that it was time for infrastructure team to be brave and learn a little bit of React and try their best at building initial deploys UI. So first version of it was just read-only. We had 2 pages. One of them you can see in the back a little bit for listing the history of deploys to just find the operations that you wanted. You could filter by services, by who initiated it, whether it failed or not, things like that. And once you go and look at the status of one particular deploy, this is when we were able to use a lot of interactive components, use more colors, and try to kind of show you the most essential information when you need it. So you would be able to find out what the status, is everything going well? We had a lot of links to other systems, like if you want to check configurations or you want to look at your graphs that you prefer, things of that nature. And in general, rolling this out to all engineering was really well received. Even there were some people who always prefer CLIs, but over time, I believe they became less skeptical about UIs, and it helped improve developer efficiency at our company. But then we got really excited. Now we have a fancy UI, let's add more stuff to it, right? So I mentioned before we were showing a diff before initiating the operation. So we still had that in deployer world as well, but the way it worked, it would generate a diff into a temporary file or on your machine, show it to you real quick, and after you proceeded with information, it's kind of lost forever, which is a bit ridiculous. Of course, you would want to find out what your colleague deployed a week ago if you suspect that this is actually causing a potentially incident in production. So if we didn't hold back and decided that let's just add this to the UI, move more stuff to the backend, show it in the UI, everything is pretty and awesome. One thing that we didn't anticipate, though, that it's actually impairing user experience quite a bit. Because what happened after we just rolled this out? You would still start it in the CLI, then UI opens up the diff, you look at it. The next thing you need to do, you need to confirm the deployment whether, like, say, it's OK to continue or not. So how do you do that? We still do it through Slack. So you get a notification somewhere here that you lost. You're trying to find that scary big Slack message, verifying that it's the right one that you're clicking in. Then you say, OK, continue. Then again, from that Slack thread, you're switching back to the UI to monitor the progress. And then if suddenly you have a failure, same thing happens, another Slack message. You're switching between tools, trying to check, is it actually an issue, alert is just flaky. And then again, you're switching between all of these tools. You're stressed, you hate the day when you actually wanted to do any deploys. So we heard from the first days of rolling this out that this is not sustainable, which was really great that we have this open communication channel with engineers. So immediately we started planning work to just move all of this confirmation flow into the UI. That really helped, and I think after that we received less and less complaints about the whole flow because it just became more streamlined. You start everything in the CLI, then go to the UI, do everything there. Hopefully in the future, we will move all of the functionality into the UI, but for now, unfortunately, changing priorities and a lot of other issues in developer efficiency space didn't really allow us to do that yet. But I'm really looking forward to the day. Another thing that showed us the value of having our own tool was the need to introduce deploy freezes. At some point, quite a while ago, we had an outage for some of the tenants where we got really close to violating our monthly SLA. And because of that, we wanted to introduce a deployment freeze to make sure that people don't deploy to production on a regular basis, and if they need to deploy something, they need to get an approval from higher management and kind of explain exactly why do we need to deploy, just to make sure that everything is going to stay safe and we're not going to violate our contract. And since everybody's working remotely, we're spread all across the globe, how do you actually enforce this? Because we've sent an email, we've sent Slack messages all over the channels, but it's still, there's no guarantee that people will actually follow through, because they might miss the memo, or maybe they just came back from vacation and they don't know that deploy freeze is in action. So adding this to the tool was actually super simple, just took half a day. And then we thought that maybe it's a little bit of an overkill that we're automating it right away, but we added it no matter what. And then a couple of months later, actually, holiday season came, and we realized that for Christmas break and New Year's, we actually also want to ask people to not deploy without actual need, because nobody wants to get paged on New Year's Eve or on Christmas Eve. So we've been using deploy freeze functionality quite a bit after and made a lot of improvements to it, but I think what was really valuable for us is seeing that it's really easy to add that when you have the tools that you built from the beginning. And these days, we're facing the next challenge, basically, because now we only talked about deployment, right? But actually releasing code to production involves way more steps. Because first of all, you have a change on master, and then you want to verify that it's actually healthy, so you run a lot of end-to-end tests and different other types of tests. After it's validated, you maybe want to cut a release candidate and deploy it to a staging environment, build for Docker images to build, update configuration, deploy it, so all of these steps just to get it to staging, and then the same set of steps to get it to prod. So again, the same problem as before, a lot of steps. At first, we automated it all as a set of build kite pipelines, but that got really messy. When something is kicking off because you made a commit somewhere and finding the full graph of dependencies is kind of hard. And we kept adding additional requirements to how we wanted to release things, and it was becoming harder and harder to support. So the project that we did recently, we actually built it on top of our deployer, another service that is kind of responsible for automating releases. And we're really looking forward to kind of when we roll it out to all our customers, and then we'll see. I'm pretty sure first feedback was already pretty good, that it speeds up the process, brings more clarity. And basically, that's the direction that we're moving on now. I have a lot of other stories about other things that we've done, but I don't have all the time in the world, and it's also really hot in this tent, so I wouldn't keep you any longer, So just wanted to mention them real quick. There was a bunch of challenges about providing more flexibility, about control over speed and safety, preventing concurrent operations from happening. We added auto rollbacks on failure, and kind of handling that was also tricky at times. We added generation of release notes, and one of my favorite ones is actually persistent disk expansion and shrinking, which were pretty important operations for us, but they don't come out of the box in Kubernetes. So that was a fun experience building that. So now let's move on to the lessons that we've learned along this journey. The first one that we've learned is that user needs are really important. And in my opinion, if you work on the infrastructure team, you're in a really lucky situation. Because your users, your stakeholders, are actually engineers, same people as you. You can communicate so easily with them, so you really need to use this to your advantage. Just talk to them. Sit down with them and see what do they do on the daily basis. Feel the pain together with them, and then together you will definitely find a good solution that you can offer them fast and will actually make them so much more efficient and happy at their job. The next lesson that we've learned, that less is more, it's kind of directly connected to the previous one. Because as you listen to your engineers, you feel their pain, you want to help them. And then it's really easy to fall into a trap of basically adding more blows and whistles to your system, addressing every request that they have, because yeah, those are brilliant ideas, they make sense. But at the same time, you can really impair a lot of other things, such as developer experience. So here you can see in the background, this is output of help command for starting deploys. as you can see, like, it barely fits the screen, but then I need a magnifying glass. I have really poor eyesight, so I cannot read this. And then if a person just joins a company and they want to do a deploy and they call help and they see this, they'll never do any deploys ever, right? So for now, we addressed it by just making most of the options kind of work by default, but the next step for us is going to be just getting a little bit more control over this, maybe remove some of the things, and hopefully also provide a better experience in the UI and have some presets for different groups of services. So a lot of ideas here, but I think this comment kind of illustrated to us that we shouldn't be getting too excited with all the user requests that we get. The next lesson that we've learned is about visibility, because it's not that hard to build a solution to a problem that works just fine in 90% of the use cases. But then what about the last 5% that you have? We are still really need to improve this in this area. In the example of when deployment fails, it's really easy for us to detect, yes, it's failed. Go do something about it. But then the engineer will ask, but why did it fail? And it's like, service is not starting up, but why is it not starting up? And the more signal we can provide to them, the faster they can remediate the issue and figure out what to do about it. So this is still the area that we're going to continue pushing the needle in and hopefully find good solutions here in our deployment system. The next lesson that we've learned is about reusability. As we were building all of these workflows for deployment, we built a lot of small components for talking to different Kubernetes APIs and all other subsystems that we have. And then later on, we started automating more operations for different other things, for automated testing, for different backup operations, different cluster operations, such as rolling restarts and things like that. And we were able to reuse all of those small building blocks. And it was really helpful, and I'm pretty sure we're going to keep building more and more blocks. Then again, we've learned a lot that sometimes you expect that something is reusable, but it's not. But then you iterate and just make it more flexible. You make it more reusable. And the last lesson that we've learned was about dependencies. So if you're working on infrastructure level tooling, it's quite important to remember that at some point, a lot of processes at your company will depend on this tooling. And we've learned this lesson really hard during a global Slack outage. Because you remember Slack integration, right? Apart from confirmation messages, we were also sending a bunch of information level messages during deploys. And then Slack had an outage, and we realized that our workflow, if it's failing to connect to Slack, not able to send a message, then it's just gonna fail as well and not allow you to continue. Again, the issue was super easy to fix. 10-line change, deployed really fast, everything worked fine, but it really made us think hard about what is actually the cost of adding a dependency. And from that moment, moving forward, we try our best that every time that we add a dependency that we need to think about what happens when it's down. Is it a hard dependency or not? What can we do in case it's going to be down? How do we work around it? What is the way to proceed with the operation nonetheless? So looking back at the last 2.5 years, I think for us, it was the right decision to build our own tool. At the same time, I do not think it's the right thing to do for everyone. The main reason why we did it, we needed that level of flexibility, we needed that level of control, especially because we are deploying our own time series database, and it's really important for us to provide great guarantees about availability of our service to our customers. We cannot afford to lose data. But at the same time, it requires a lot of resources. It requires a lot of time. It requires a lot of care. It requires someone to actually not just solving the problem, but thinking about what is the experience going to be like for the stakeholders that you have at the company. And it's a lot, and not every company is ready to pay that. And that's completely fine, because there are a lot of other solutions on the market. But I hope that we will just kind of keep pushing the needle forward and do our best to balance providing available and reliable service, fast rollbacks, and all of that together with providing good developer experience. So now, if you have any questions, you're really welcome to ask them. Otherwise, you can contact me over there or find me later. If you want some swag, if you like stickers, we also have nice t-shirts and socks. Just come over here. I will gladly share them with you, so then I don't have to carry them back home.
doesn't love a good swag, right? Everyone loves. I got this craft t-shirt. All right, we have some questions. Let's do this.
Great.
How do you get feedback from the users to know what is working and what needs to be changed?
So we have a lot of channels for feedback. From the start, we created a separate Slack channel and announced it widely that this is where you go if you have any issues. Another thing that we were doing is sending out monthly newsletters about the things that we kind of been working on, the plans that we have, bugs that we have fixed, things like that. And everywhere we would mention, just go to the Slack channel. In addition to that, I work in general on a dev efficiency team. So it's not only deployment tooling that we support, but a lot of other products. And basically, we host feedback sessions, normally like every 6 months. We host them in order to gather feedback. We invite every team into a separate meeting. They're really welcome to join. We kind of just invite them to share anything. We don't really limit it to tell us about your deployment pains. It's just okay, everything that you feel makes you less efficient, just bring all the rant and share it. After that, we gather that feedback together, try to figure out what is actually that we can fix real fast, what requires a long project work. And another thing that we started thinking about more is that feedback sessions are great. I love them, and I hope we will keep having them. But at the same time, it's only loudest people in the room that you hear. And also, a lot of the time, people kind of get used to the pain. Because there were a lot of issues when we were just checking the discussions in the on-call channel. It's why didn't you tell us that it takes this long for you to initiate this process? Why? It's but this is normal. It's been like this for months. So for that, we're actually added a lot of metrics for different stages of development lifecycle. And we're still trying to come up with the best metric to track because there's so much data and so many things you can measure. But hopefully, together, feedback and metrics can give us the full picture of that.
All right, thank you. As of today, has the deployment market changed that you would pick a commercial option, or is your homemade tool still the only good fit?
Really good question. I agree it has changed a lot. But I think as long as we need to support deploying our time series database, and that requirement is not moving anywhere, I feel like it's going to be hard to integrate with it. And actually, one of the things that we're seriously considering, all the operators that we have, they're becoming quite a pain to maintain. So we're actually thinking about kind of pulling it all into temporal workflows because it's easier for us to kind of reason about the order of operations, especially when you need to do a lot of changes to the cluster, you need to do them in a specific order. We still need all of the custom health check-in. We're adding more of that to make sure that our deploys are safe. So I don't think there's a way back for us, but we will keep assessing. Hopefully at some point, maybe something will come along and it will be a smooth migration because, migrations are always smooth, right?
Maybe smooth, maybe not.
Yeah.
All right. Did you consider ditching modeling tenants into the deployment architecture? It seems it was the main driver of complexity for the pipeline.
Yeah, I don't think we can skip that because we still need to be tenant aware in a way. Because quite often when a new customer comes in, maybe they're requesting some new features from us that we're developing really fast. One thing that we're really trying to fight right now is kind of drift between configurations of tenants, and we don't want to have snowflakes, but they will keep on happening. We're trying to minimize it, but I'm not sure it's going away in the near future.
All right, thank you. Last but not least, are you using the concepts of rings for deploying trickle-down to groups of customers?
Not yet, but we wanted to kind of have a bit of right now we just have batching. Basically, let's say one team decides to deploy 5 tenants at a time, or another one 10, some all in parallel. Kind of really depends on the team. But I think we've been discussing it a lot in the past, that we would like to kind of group tenants by size, group them by the subset of features they have enabled, and kind of figure out the order. It's still in the plans, but I think right now we're focusing on a lot of other projects and a lot of other improvements to our deployment system, so it's not going to be in the near future, I think.
All right, thank you very much. Let's give a warm hand to Mary.
Thank you.